Welcome to our town hall for the Human Cell Atlas. Really excited to have everyone here. I know I can see that people are still coming in, so we're going to wait. Wait a few moments for the numbers to really rack up until we get started. We have a nice full agenda, but we also saved an hour and a half for the meeting. We think we won't necessarily need the entire time, so we'll just go with the flow and the questions that we get. And I think the numbers are stabilizing nicely, so we can really get started. So our plan for today is very simple. Sarah and I will give a brief presentation about some of the key topics that we've happened in the nearly 5 months since the last HCA town hall in December, and then we will turn to a panel discussion. If you have questions, even during the talk, just put them in the, I guess it's a chat or a Q&A, in the Q&A function, and we will answer all of them during the panel discussion. So Ellen, if you can, yeah, we're already on the second slide. So we will give a preview today after the general updates. Sarah will give a preview of the HCA general meeting in Toronto, as well as how we plan to engage the entire HCA community into integration and annotation of the Atlas over the next year. And then we will have the panel, as I said. Okay, if we can go to the next slide, Ellen, please. Let me give you a general highlight of the recent activities that have happened since December. So first of all, it was a very exciting period because of the HCA work around the integration of the tissue atlases. Many people have contributed to that, and we're very grateful for all of these efforts. You're going to hear in more detail later from Sarah on work underway for the first 6 pilot atlases. And over the next few months, also, we'll be engaging with the remaining Bionetworks to start the second wave of curating data sets for each tissue in preparation for the integration process for additional atlases. So if you're involved in a separate integration effort for your organs or your tissues of interest, would be great if you could let the coordinators of your biological network know, because we really would love to leverage all these other efforts as much as possible. Now, while speaking about the different biological networks, we really want to thank the coordinators of the 18 biological networks. They are investing an enormous amount of time and effort in trying to convene everyone together, helping draft the roadmaps. There's many pieces of those now, collecting the data sets for the integration projects, coordinating experimental work, and more. These bionetworks continue to be really at the heart of the HCA work in the months and the years to come. And we really couldn't have been as successful without the work of the coordinators and everyone in the bionetworks. And in that context, it's great to remind people that there's going to be a meeting for the bionetwork coordinators on May 22nd. They're going to review progress on the Atlas integration, and they're going to start planning annotation jamborees over the coming year. So if you're a network coordinator and you didn't receive the invitation, please let Ellen Todres know. You can do it even in the chat right now, or you can send her an email later. A second important development has been the work on a very large bundle of HCA publication that we hope could come out later this year. So in response to our call last fall, and first to the Bionetworks and then the December town hall, the members submitted 86 abstracts. That's actually quite the record as far as we understand for bundles in general. We have now had those reviewed by editors in Nature Publishing Group, in Science, and in Cell Press. And all 3 of the presses have a very strong interest in our bundle. We're working with the organizing committee and with the HCA publication committee to determine the best option for publication. The abstract, just to remind you, are in 3 general categories. There's analytical methods papers, papers focused on developmental biology and the developmental cell atlas, and papers focused on atlas integration for specific organs and tissues. There's also additional papers in the bundle on the work of the HCA Ethics Working Group and the Equity Working Group. So we expect the analytical papers to be submitted next month, and the others would follow in the summer. There's going to be opportunities for additional packages. This is by no means the last one. It's actually the first one. So if you're working on a paper that you think will be going out later in the year or even next year, we'd love to hear your ideas, and you can email info@humancellatlas.org. More details on that will be coming soon. Because of the different options, we have to make a choice or choices on where we will be headed, but it's really exciting to see the enthusiasm actually from the presses on publishing this very large boundary. The next highlight coming up is, or the next major event that happened already is the HCA Africa workshop. We had support from the Chan Zuckerberg Initiative, as well as from the Bill and Melinda Gates Foundation. And together, this allowed HCA to organize the first in-person HCA Africa Computational and Experimental Design Workshop. I don't know if anyone followed it, but you could see even images that people were posting on Twitter, and you can literally see things that were happening on the computer screens and how people were analyzing data from different HCA datasets. The overall goal of the 4-day workshop was to bring together African researchers and scientists so that they could gain expertise in both the experimental and the computational side that is needed to build atlases. There were 60 researchers coming from 11 countries, including Ghana, Nigeria, Ethiopia, Zambia, Malawi, Mali, Cameroon, Kenya, Gambia, Senegal, and South Africa. And we're really grateful to the University of Ghana and the West African Center for Cell Biology of Infectious Pathogens who hosted the workshop. We're planning a similar workshop in Chile in October in collaboration with the HCA Latin America Regional Network. And then there will be additional workshops in the Middle East and in Asia. We're going to see in a moment, not just yet, the map of HCA and really how broad the span is now. And these kinds of workshops are instrumental in doing this. I also want to thank all the people who participated in this workshop in making materials, designing the tutorials, running it, and so on. Okay. There's also a few new appointments to announce. So our organizing committee has recently elected 6 new members, and these are Fabiana Arzuaga, who is a bioethics expert from Argentina, Christoph Bock, who is a computational biologist focused in Vienna, actually the host of the previous general meeting in Austria, Shyam Prabhakar from the Genome Institute of Singapore, Patricia Severino, who is a Brazilian researcher and a co-leader of the HCA Latin America Network, and Christine Wells from the University of Melbourne. And you can see that we had a wonderful diversity in our new members in many ways, including gender diversity, as well as excellent geographical diversity, representing really now where our membership is. The organizing committee is a really crucial part of HCA's work. It's our decision-making body. And it's really important that it has representatives from across the world. So having new OC members, 2 from South America and 2 from Australia and Asia, really ensures that our scientific decisions are carried out by scientists that really represent where our membership is. In addition, our executive office has 2 new positions that have come online in the last 6 months. In February, Lucia Robson joined as a senior program manager, and she's based in the UK office, and she is supporting the CZI-funded Atlas Integration Project, of which you're going to hear a lot in a moment from Sarah. And just this month, we added a new events and administrative coordinator in Singapore to expand our capacity to support meetings and workshops and other outreach in Asia and Australia. This is Esther Chua, and she's going to be based in the Genome Institute of Singapore. And we hope that you would have a chance to meet Lucia and Esther soon, especially in the general meeting, and join us in welcoming them. I promised to show a little bit of numbers. There's been a lot of interesting new numbers in the HCA. We've had a few improvements also in the HCA website, including a redesign of the news page, featuring recent HCA announcement and media articles. And you're seeing a little bit of a screenshot from the website on this slide. And it's really fun to see the numbers. Maybe I'll highlight a few. The number of cells at 117 million. This is actually, I believe, before the survey that is running live now. So these numbers will be updated soon. You can really see the geographical span. For sometimes we run it as a movie. I think seeing what is happening in the global south and in ELMI countries in terms of representation is really exciting. And we're very grateful for the regional networks for having brought HCA to scientific communities across the world. We almost are 3,000 members from 94 countries and 1,500 institutions. And the number of HCA formal publications is 125. We're actually working on figuring out the number of citations of these papers to really indicate the impact of HCA data and publications. You can find this information on the new webpage that collects information about our consortium in one place, and you find it in the About HCA menu if you go on the website. Let me turn now to the next slide, Ellen. Great. So we're going to turn to a quick preview of the HCA general meeting. And with this, I will actually turn to Sarah for the next bunch of updates.
Thank you, Aviv. It's a pleasure to turn to a preview of the HCA general meeting. And if we go on to the next slide, we're once again looking forward to seeing many of you at the HCA general meeting this summer, either in person or virtually, as it'll be hybrid. In person, the meeting will be held at the Mars Discovery Center in Toronto, Canada, obviously from July 10th to 12th. And we're grateful to Gary Bader for serving as our local host and chair of the program committee. And Gary will be joining us for the panel discussion later. He's in the panel here. At this point, the in-person registration has reached capacity. You can still join to attend remotely, although the in-person capacity is full at this point. And of course, we'll also post the videos on the HCA YouTube channel. If we go on to the next slide, we'll see the sessions for the meeting, just as a sneak peek for the program. So the first, so as I'm sure you're all aware, we're now in the era of building the human cell atlas, in the sense that there's enough data that we can integrate data sets. And so the first day is going to be dedicated to evaluating and enhancing our approach to building atlases, talking about how do we define the version 1.0 of the atlas, and how can we together move towards better integrations. And that includes not only experimental and computational methods, but also the building of scientific communities, the computational integration pipelines, the feedback with the Bionetworks, and consideration of ancestral diversity. The second day is going to be dedicated to a very technology, both experimental and computational focus, including spatial methods, new dimensions to enable new questions, machine learning applications, and the cell ontology and annotation. And then the third day, we'll have a more general overview and consideration of how should we think about cell function, what's the path ahead, how will the atlas be used, and then emerging ethical issues. And so that gives you a little bit of a sneak peek and a heads up on the program for the general meeting in July. If we go on to the next slide. Great. And so this then brings me to the topic of the biological networks and engagement with atlas integration. As I've already indicated, it's a sort of topic of our time, of the era that we're in for the human cell atlas and for the general meeting. So over the past 4 months, we've had 6 pilot integration projects that have progressed substantially. And you can see here in the depiction, we've got a little picture of the organ, and then which stage of atlas integration the organ is at. And we've got a little pathway going from actually defining the scope, defining the data sets, metadata processing, QC and batch analysis, and so on, and all of this as phase 1. And then phase 2 in the technical sort of consideration is cell label harmonization, in other words, harmonizing annotations, seed annotation, integration benchmarking, and then finally data integration, clustering and marker detection, re-annotation, Jamborees, and downstream analysis. And you can see the organs that are kind of at different stages of this are the one that's furthest ahead down in the bottom right is version 1 of the lung, and the lung Bionetwork, has just been amazing under the leadership of Martina Wayne, and others on Sasha and Jay and so on, who've worked together on coordinating the Bionetwork and working really beautifully with Fabian and team members on getting that that integrated data set online, and also there's a publication online that you can around this. And then there are other networks that are sort of further towards the beginning of this pathway or roadmap, including the gut, the kidney, the brain, the blood, the eye, and so on. We've got Chloe here who will talk about immune and blood potentially later, and also the cell annotation platform. And so these are the overarching concept here that works really well is that we have the Bionetworks who have the biomedical expertise for each of these areas working together with analysis working group members, postdocs and group members who have computational expertise, and that it's a collaborative team effort to get towards a sort of gold standard snapshot integrated data set for each of these organs, where we have many publications from the human cellulose community charting the healthy reference data for these networks. And so over the coming months, the organizing committee, so the initial pilot integrations include sort of Jamborees, and I'll come back to that later. If we go on to the next slide and look forwards for the sort of plan here, is that we are now, we've now tackled these 6 pilot projects that I just mentioned. What we want to do is look forwards to wave 2, and where the organizing committee will decide with the Bionetworks which organs and which systems and so on are best suited to go on to the next cohort of integrations, which we expect to start this summer, sort of after the general meeting. And the factors that are important to consider for whether there's enough data for a tissue is the volume and quality of the data that's available, engagement from the Bionetworks and the biomedical experts in that community, because that expertise is obviously crucially important to the quality of the integration and the interpretation, and also whether there are any other integration efforts that are happening in parallel that we can leverage and work with. So I'd like to give a shout out there to please contact Bionetworks, contact us if you're involved in an integration effort for any tissue organ system that can synergize with this overarching HCA integration program. So what are the lessons that we've learned so far from this? In order to optimize the process of integration going forward, the data curation has been more time consuming than expected. And so we need to start curation efforts, just data set curation efforts as early as possible. The Bionetwork coordinators will be asking them to be in contact with their networks over the next few weeks to involve them in preparatory work around this and collation of available data sets. And so if you're interested in, if any Bionetwork is interested in being involved in this, please think about the available data sets, how many, the quality, and putting them together. And one thing I also want to highlight is that we're at the beginning of this journey. We are only talking about initial integration version 1.0 for each tissue. There'll be many opportunities in the future to add version 2.0, 3.0, et cetera, and refine the integrations, refine the annotations, and so on. So if we go on to the next slide, then this is just a highlight on what I mean, or what when we talk about annotation jamborees, what is it that we mean? So if we just to say that once we have the initial integrations, what we found really helpful is to have cell annotation jamborees where the relevant Bionetwork community works with the computational data science community and supports cell annotation efforts, and different experts kind of work together to harmonize cell annotations And this is really an exercise around engaging scientists globally to have a range of perspectives on developing robust consensus annotations of cells, tissues, and so on, and updating the relevant cell ontologies so that we kind of progress to a gold standard sort of set of annotations. And so this process will involve some variation for each bionetwork, but we can provide a blueprint of things that have worked well, for instance, for the lung and for other bionetworks, and then tailor the Jamboree to the specific needs of each bionetwork. And we imagine there'll be some prep work in advance for a bionetwork, and that the Jamborees will vary from 1 to 3 days or so. And we could hold them both in person or virtually or hybrid. And so what we're anticipating is that some Jamborees will start this autumn, so September, October, and we'd like to have Jamborees for those 6 pilot projects completed by early 2024, so by the end of this year, beginning of next year, and then to have the remaining bionetworks from wave 2 in later 2024. And a key resource for annotation, we hope, will be the new HCA Cell Annotation Platform, or CAP. And that's designed to facilitate consensus annotation of data sets and to be a tool for communication of different annotations and harmonization of annotations. The HCA Executive Office and the CAP team will be in touch with bionetwork coordinators and will help each bionetwork organize their Jamborees. So just then on to the last point, which is a heads up on the upcoming HCA events. If we go on to the next slide, just a heads up for people. We have a spatial omics Bionetworks seminar virtually on the 11th of May, then the general meeting in July that we've talked about. Middle East virtual symposium is planned for fall 2023, and we're finding a date for that. A Latin America computational workshop in October in Chile. HCA Asia annual meeting, as every year, this is becoming a kind of tradition, will be in India this time, which is exciting, in November. And then an HCA Asia workshop in the spring, and an HCA Middle East workshop, which we're also planning in roughly a year's time. So that's kind of an advanced planning, an advanced heads up on the events that are coming up from our amazing HCA events team that supports all of these, and that we're really grateful for. And that really brings me to the end, and I would like to say thank you and introduce John Randall, the Chief Alliance Officer of the HCA Executive Office, and he'll introduce the other panelists and moderate the Q&A, and we look forward to the questions and discussions. Thank you.
Thank you very much, Sarah and Aviv. We are now joined by additional members of the HCA Organizing Committee. I'll introduce them in turn. I'll start with Gary Bader, who's a member of the Organizing Committee, but also a leader of the HCA Liver Biological Network. He is also our host for the HCA General Meeting in July in Toronto. So we're very much looking forward to seeing him there, and thank him for the work that he's doing leading the program committee for that meeting. Fabian Theis is at Helmholtz Munich. He is, in addition to being a member of the Organizing Committee, also a member of the board of the HCA nonprofit, HCA Incorporated, HCA Inc. as we call it. He's also a PI on the integration project and involved in a number of other efforts with HCA. And finally, Chloe Villani, who is at the Broad Institute, MGH, and Harvard Medical School. She is also a member of the Organizing Committee, a leader of the Immune Biological Network, and also the lead PI, as you've heard, on the cell annotation platform. So again, all of our panelists play many roles in HCA, and we're really grateful to them for being here. As questions are still coming in, I'm actually going to lead off with a couple of my own, and then we'll turn to some of the questions in the Q&A. I want to ask first, because several of you are involved in a project that just kicked off this month. It's funded by the Canadian Institute for Advanced Research on the multi-scale human. And I'd like to ask if you maybe one of you could talk about the goals of the project, but particularly that challenge of integrating multiple data modalities across different scales of space and time. I don't know who wants to lead off with that question.
Yeah, happy to take that. So the idea there is basically twofold. So one component is mapping across scales. So with HCA, we've got these beautiful deep molecular maps of cells and tissues. And a question is whether we can actually link that to a large volume like light sheet imaging that's obviously much less multiplex, and even sort of whole body synchrotron scattering imaging that's purely morphological. So is essentially the CFAR is sort of a think tank, a workshop to think about approaches that we could use to link maps of the human body at different scales. So that's sort of the one pillar. The other pillar is, if we could someday do that, would it be possible to actually model perturbations across scales? So that's the second pillar. And for instance, for the climate, there are these multi-scale models that are nested, where you have, say a perturbation in one part of the world, and it's then possible to predict what will be the impact on the weather and long-term climate in a completely different part of the world dynamically over time. And these sort of class of nested or multi-scale models are used for climate, they're used for the ecosystem and so on, but they've never really been developed for human physiology. And so that's the second kind of pillar of that program. And Gary has put a little website into the chat, and then Fabian has his hand up, and as does Aviv. So I'll hand over to them.
Yeah, I just wanted to briefly extend and sort of just express the excitement. I think I would say, even though we call us Human Cell Atlas, it might be hopefully not too critical to say we don't really care about that individual cell, right? But sort of people start thinking how little tissues are formed. I think if you came up with at some point multicellular programs and so on, and these next steps. And I still find it that on the cellular level we use this metaphor of cell type so much and so easily to communicate about whatever findings we have. But as soon as we go to a bit larger, or maybe also to submolecular scales, it gets harder. And I think then connecting this could be, independent of the findings, also a fantastic exercise, and also I think challenge for the machine learning side of things, where you mentioned climate modeling and so on. I think all these large scale models, they come from these physics-based things, where there's finite elements, ODE, these type of approaches. We know that they don't exactly now work on the cellular scale. So to bridge these approaches, I think we potentially also need a bit more math, and that's why I think this could be a very exciting direction for the whole project to contribute.
So I will highlight 3 additional points. The first is that this was always the goal of the Human Cell Atlas. So in the white paper, we highlighted the importance of mapping cells into tissues, and also going from tissues to organs in a whole common coordinate framework for the human body. But we also knew that this would take some time, and we're now kind of in this transition phase into this new phase of the Atlas, where we can really do this work, both because we have enough data from lower levels of organization, like the cellular level, and because methodologies have advanced, both experimental methodology and computational methodology. And even for the computational methodology, it was clear about 5 years ago that this is coming, but it takes things time to mature, for the data to be available and for the modeling paradigms. So that's really something whose time has come, and that's very exciting. The second point that I will make is to emphasize that there's 2 kinds of questions that we get to answer using these multi-scale models that I think are very important. The first one is really a fundamental question in biology of how the different levels of organization of our body are connected to each other. So instead of looking at each of them in isolation and saying, these are molecules, and these are cells, and these are tissues, and these are organs, in the end, there's only one human, and one layer leads to the next one. And understanding this causal connection of how one becomes the other is one of the biggest questions that exist in biology. And it's very exciting to be able to start answering it, first by just relating them one to the other, saying this transforms into that, and then looking at the causal regions, the causal reasons where perturbations really help us understand that. The second is a very pragmatical point. Many of these things could have huge implications for human health, for understanding patients, for doing better diagnosis, for many things like that. And patients every day are treated or actually diagnosed by really testing them in many different ways, poking and prodding in order to obtain samples and looking and so on. Anything that we can understand about how the scales relate to each other, and especially with the advances from machine learning algorithms, means that we might be able to take information from one level and measure only that information and predict information in other levels. And there's things like that emerging like live right now, which I think are extremely beneficial for patients. And we have a real possibility coming from the Human Cell Atlas because of the richness and the breadth of our work, and also the tightness between our experimental arms and our computational approaches to really make that a reality. There was a beautiful paper actually, I think last month in Nature Medicine or something similar, that showed how Raman microscopy is used in the OR, in the operating room, where they obtain a sample, they never go, they never stain, they don't do anything while the brain is still open. This was in brain tumors. They use Raman microscopy and an algorithm to try and predict the genetic status of the tumor, and that directs what the surgeon is going to do in the operating room live. Things like that are things that will be enabled by our atlas. So this multi-scale modeling has real implications for patients' lives.
That's great. Thank you. Thank you all. We have some great questions coming in the Q&A. Before we get there, I do want to give Chloe a chance to expand a little bit on the plans for the cell annotation platform and ask her for any updates that she can offer and what it can offer to the HCA community.
Thank you, John. Briefly, perhaps I'll update 3 things. The first one is we've been quite involved in outreach activities, interviewing different Bionetworks to kind of get their feedback on what user interface they think that may be helpful to improve their annotation. And so if we haven't talked to you yet, please look at your emails. We've been reaching out actively. If you'd like to engage with us, you can email me directly or go on CAPT and email us, and we'll schedule some interviews. The second part is you'll be hearing a lot from us in the coming month about annotation metadata. I think the whole community has been used to gathering metadata about the experimental computational samples, but it's actually very important to collect metadata about your annotation, the evidence you have for calling a cell entity a certain way. And so we have a schema to distribute, and want to briefly explain why you should all care about this. This is about us building consensus annotation, figure out why we agree, why we disagree, and it'll be very key as we try to conceive our general atlas to come in an agreement. It's also important as you try to perform quality controls on your embedding, and so we'll be in touch. And the last point to raise is that we continue to engage with our larger computational biologist community, including Fabian, who's on the call, and continuing development of methods so that we can carry on being on the forefront. So we're making great progress with implementing annotation transfer models on CAP, as well as de novo predictions, and these tools should be available to you all already by fall 2023. And please reach out if there's specific methods you'd like to see on CAP. Help us help you all. Look forward to staying in touch.
That's great. Thank you. I want to, we did have a question early in the webinar that I want to make sure we do answer about HCA's presence in India. We do have a member of the organizing committee in India, Partha Majumdar, who is also, as you heard, leading the organization and hosting us actually in Kolkata in November for the annual HCA Asia meeting, which is quite a sizable gathering. So certainly hope that many of you can make it to that meeting as well. Partha is also actually a co-chair of the HCA Equity Working Group, which is actively considering and sort of discussing how to really assess diversity in participation as well as in HCA data, which is also the topic of another question. So I would just ask you to stay tuned on that one. There are a couple of questions related to disease atlases. A general question about linking disease atlases to the Healthy Reference Atlas, and then specifically a question about a breast tumor atlas. And so I'd like to ask if any of the panelists could address that topic. Aviv?
I can get started. I think the HCA is definitely about the Healthy Atlas as a reference. And one of the key areas where it's a reference to is as a reference to disease. So while the integrated atlases themselves are not disease atlases, and I'm going to defer to Chloe to make a comment on that for the immune system, because there's a slightly different perspective on how you treat that. So I'm not saying that, Chloe, you will talk about this, I'm sure, in a moment. We do have efforts that come from both HCA member labs and in the integration of those labs and their participation in disease efforts that do bring these two worldviews together. And so Sarah and I actually had a review together with Jenny Rood and Aidan Martins earlier in the year in Nature Medicine that highlighted the dozens of diseases that have been analyzed at the single cell level and the many ways in which the combination of the reference healthy data and the disease data together led to insights in these different diseases. What I'm seeing going forward, and these are things that were even foreshadowed in the general meeting last year in Austria, and I think we will hear more about in the general meeting in Toronto, is that we're seeing now many applications where these data are not just aggregated together, but are actually integrated together in ways that allows you to query all of them in order to find cell states and other information that is important as you're trying to understand disease. Now, there's many disease atlasing efforts. For example, in the US, the NIH funds one called the Human Tumor Atlas Network, which is focused on cancer. To those asking about breast cancer, yes, there's a particular efforts there to build breast cancer atlases, both for primary disease and for metastatic breast cancer. And so there's a major effort and some of that data is already available. There's efforts in like the kidney precision medicine program, KPMP, that focuses on renal diseases. I just gave two off the top of my mind. And many of those efforts are actually working very tightly with the HCA, including through joint coordinators, people like Matthias Kretzler, for example, who's both a leader in KPMP and in the Healthy Kidney Atlas. So those, I think, connections are well established through our community. Chloe, I'm turning to you because I think in the immune system, it's a little bit different than the statement that I've made, and I think it's important to highlight that.
Yes, we had, so I agree with Aviv that, at the roots, we are here to first establish a foundation of what is a normal system, in our case, a normal immune system. But our community has reasoned that because by nature, immune cells are so plastic, if you want to reveal the full breadth of immune cell identity, we actually need to also map them through the lenses of perturbation. And here, perturbation could be a disease. Now, I want to clarify that we're using disease really as an in vivo perturbation to really map the spectrum, as opposed to creating detailed map of every single immune diseases. And so as a first integration effort, you've heard during the town hall presentation that we started with blood just as a foundation and a pilot. And as part of this integration effort, we included both normal blood as well as COVID, because there's a breadth of data set out there to try to test our hypothesis that through the lens of perturbation, we can capture a greater breadth of cellular identity. And so if you'd like to hear more about this, I encourage you to engage with the Immune Bionetwork and to my Immune Bionetwork. I will be in touch very soon with some follow-ups and updates.
And maybe if I could just add from the liver bionetwork perspective, I don't think that I think that idea is actually likely to be seen in other tissues. So in liver inflammation affects 25% of the world. We're collecting information, whether we like it or not, just by collecting all of the healthy samples that we're getting. And I like the idea of a spectrum, because as we map more and more, we'll probably see that spectrum taking shape. And then the question is, where do we draw the line? And we probably don't want to draw a line. We want to just collect everything. But I guess from the perspective of the HCA, we're focusing on the healthy part of that spectrum. But also everyone in the liver bionetwork, and presumably all the other bionetworks, is very interested in disease. In their labs, they work on their interest in disease questions. And so when, we've seen this in the lung atlas that has published a version on bioRxiv, and will also happen for the liver version 1 atlas that we would like to publish. We'll have a healthy and a disease map. We'll have healthy and disease maps. The healthy maps are ones that we're collecting via this in the HCA, and the disease maps will just be pulled from everyone who's publishing in that area. So that will also help us test the idea that the reference is working well as a reference for disease, because we'll be doing those comparisons and understanding what the power of those comparisons are.
Great, thank you. Let's see, again, a number of really good questions in the Q&A. I want to ask the question about quality control, and maybe post this one first to Fabian and ask others to comment about how does HCA really cope with the variable quality of data sets in Atlas integration?
Maybe I can take this first. So with integration, right, we now mean that we don't just take a single data set, but what Aviv and the others now sort of said, and what we've been trying in a few data sets using some of these machine learning based integration methods to essentially, how did Dana call it, smoosh things together. And obviously in the smooshing or integration process, we want to be careful not to remove biological variation. That's why I think also, Gary, Chloe, what you've been saying with disease variation is, I think, such an important point to make sure that you sort of leave these things there. Having said that, I think the question is very valid. What do we do in order to integrate now all these quite heterogeneous data sets, often with different measurement protocols, sometimes with very differing sampling procedures? And I remember early on in early HCA meetings, we tried to standardize a set of protocols and make sure, this is sort of the way how we sample from various organs. And turns out that many of these things are hard. We've been gathering quite a bit of expertise in QC when we build this integrated human lung cell atlas, which is about to come out now. And what we realized, even within a study, let alone across studies, that, for example, sampling location was such a big confounder, or not confounder, I mean, just a natural sort of variation. So that, for example, relative cell type frequencies were strongly varying, just depending on how you select, right? So in order to make QCs, I think imposing such constraints could potentially really remove too much of variation. But what we of course do in practice are standard QCs for just single cell inclusion, such as mitochondrial fraction per cell, number of genes, and so on. But then across the different samples, so across the different studies, we have a list of a criteria that could be used to potentially filter a subset of cells. In practice, though, and I think that's what the general idea is. And what I think, Gary, you also alluded, we don't really want to draw a particular line. We just want to make sure that whenever we integrate, we get uncertainty scores for each of the cells, or potentially also studies where we are sort of sure about them particular overlapping. In many cases, I think in PBMCs in particular, I mean, Chloe, you said this, these things are typically very good, overlap strongly. You can even start calling QTLs and so on. In other settings, you think about cancer, but then potentially also going to organoids and so on, protocols and variation is so strong that this becomes less clear. And then this needs to be taken additional accounts. But I think the key message here is there's no one size fits all. There's no single pipeline how you can do all these things. And I'm a computation person, so I had to learn it really the hard way, that there's so much differences across organs. I remember when we first went to a brain integration discussion, the variation that you see here across localizations, I think Dan Lovely, maybe Ed Lovely said the brain is something like 100 organs in one. So we need to adapt these things. There's no one size fits all. We adapt them to the particular settings, but we have a set of standard underlying QCs that we are happy to share. And we're actually just writing this up also in a small review.
Thank you. Any other comments on that question?
The only comment I will make is that I fully agree with the point that data quality can vary between data sets, but I'll just emphasize what Fabian said, that the tools we have today sometimes allow us to incorporate a lot more than we might have incorporated in the past. And in the past, people had to draw a very firm line and say, this is just not good enough, we can't use it at all. Often we find that good data really salvages weaker data. And if these weaker data come from a rare sample or have other unique features to them, that's one of the strengths that we actually have. So as the data grow, they actually, in a sense, become more forgiving in the integration effort. So I think we are trying to be very mindful around this. And this is why this is also, it's essentially a research activity. And we have these teams really looking deeply into exactly these kinds of questions together with experts.
Great, thank you. Dorit Hockman asked a really good question in Q&A because HCA is not just a collection of individual organ atlases. We really need to think about integration across tissues as well. So she asked whether there's hope to be able to adopt a standard method for annotation across all organs to allow integration of all cell ontologies for all organs, or is the hope that it will be possible to build the atlas using diverse annotation approaches? So I think, Chloe, you're the obvious person to take the lead on answering this question, and then others may comment.
Well, thank you so much for this question. And that's the entire purpose of the cell annotation platform, right? And that's why we're encouraging everybody to share the annotation metadata within the schema we are on the verge of circulating. So as a first QC steps, the researchers can define their cell annotation with sufficient evidence of why they annotated their cell a certain way, to allow resolving and distinguishing agreements and disagreements between how cells are defined. It's going to become a foundation to help resolve disagreement, specifically in the second step of post-integration, where researchers can then use this annotation to work with the integrated atlas to define their annotation. And we welcome feedback on if there's specific ways you'd like us to refine the tools of CAP to empower the community to do so. But that's a whole purpose of CAP.
That's great. Thank you. Sarah.
So just to add to Chloe's description of CAP, I would say that I see annotation sort of in multiple phases or waves. And of course, the first wave is sort of expert and knowledge based. These integrations and the interaction with the Bionetworks and the CAP will contribute to a set of consensus annotations. Of course, in cell ontology, sort of controlled vocabulary for storing annotation names is a useful additional tool for that. Sort of maintained by our colleagues at the EBI. What there'll be, hopefully, will be a second wave where basically or in an iterative way that we can learn models from the data-driven or from the expert annotations. We can learn machine learning or deep learning models, and there are a variety of methods for this. There's Azimuth, there's cell typist, there's the sort of overarching models, the SC arches kind of thing that Fabian can sort of elaborate on, which are global modeling objects globally for label transfer. And that then in the long term, everything will, new data sets can be automatically annotated like that. And so I sort of see that sort of progressing over time in that way. Aviv, did you want to add?
Yeah, I'll add one cool thing that I don't know if people have noticed already, but it's happening. People are using large language models to annotate their data now. And it's quite effective too. And I mostly say that because it's a very time-consuming effort to go through the literature with my marker genes and seeing this and that. And I wanted to encourage people to try it because it works quite well. It doesn't necessarily entirely take you out of the loop. It has some issues with robustness and reproducibility, but it is a hugely time-consuming step. So even though it's not directly related, since there's many people who then see it and annotate their data, I thought it was nice to give a plug, not my own work.
Thank you. The question about SCEQTL studies. How do we think about data integration in cases where we expect genetic variation to be responsible for some variation, but without regressing out such effects? Aviv, do you want to take this first?
I might say that it always depends on the use case. So the genetic variation between individuals is true in any study that we do. The SCEQTL studies are usually powered enough, meaning they have a large enough number of individuals, and they have a particular question in mind. They want to ask a genetic association question. For different features, including EQTLs, you can actually ask other questions about, you can ask questions about, for example, cell proportions and other things. They're powered for that, but it's also in the eye of the beholder. It's what the person actually wants to ask of the data. And so how we treat variation really depends on the question that we're asking. And rather than feeling that there's one answer that fits all, I think it's important to develop models that have parameters that are tunable so that you can dial up or down the kind of variation that you desire to see. And even in a single study, in one study, you can say, well, first, since we started the annotation, I will stick to that. First, I might want to reduce variation and find the shared component so that I can answer questions like annotating all my cells. Once I have done that, I want to dial it back and actually increase the inter-individual variation so that I can ask other questions about inter-individual variation. These are just part of the analytical process, and it goes hand in hand with the question.
Great, thank you. We have a question about diversity or inclusivity about data. I will say this is a little tricky to answer because we're still really in the process, as you've heard, of actually curating the data sets that will be used in the atlas. I think the early indications are actually very positive. So two of the most advanced integrations right now are the eye network, or rather actually specifically the retina atlas, and then the immune atlas, both of which are actually quite far higher than the sort of historical average in GWAS studies and other genomic studies about inclusivity. This is clearly something we're working on. There's a lot of effort both through the CZI-funded Ancestry network, but also other projects to really increase data generation in underrepresented regions. But we are tracking it, but it's still very early since we're still collecting data sets. It is one of the criteria, though, for which data sets we're curating for each atlas. So thank you very much for that question. The question then specifically about blood single cell data for monogenic neurological diseases, and interested in perhaps starting a network on that. Maybe Chloe, could you comment about any existing efforts or how that network could get off the ground?
I think this one I may take. I'm not sure if you are a member of the Immune Bionetwork, and if you're not, I invite you to reach out. We can help coordinate. Our phase 1 of the blood is focused first on normal and COVID, but phase 2, in addition to tackling other immune tissues, we'll be integrating additional diseases, and that could be an opportunity to engage with this effort. And so you can, if you go on the HCA website, you're going to see our email address to contact us at Immune Cell Atlas.
That's great. I should give other people a chance to comment on recent questions. Does anybody else have anything to say?
I can comment on the one on Jay Shenduri's recent paper on using a tree-like abstraction to represent cells rather than an atlas. I think, to be fair, the atlas itself has said the term atlas was not meant to convey a particular way of representing cells relative to each other. It is more about the fact that you need their collection. There are many ways to represent. The two things that I would highlight, the first is that the cell ontology, for example, is exactly this kind of structure, and similar ones are used in different sub-atlases. So I see no conflict there. To me, it's a little bit of a false dichotomy to say this versus that. Yes, it's an absolutely important construct. However, that construct is simply as well insufficient to capture all the different ways in which we think about cells. So we simply need to have enough abstraction flexibility where a lineage is one of the ways. It's a developmental point of view of cells. However, cells, and Chloe in the immune system would feel, I think, nicely resonant with that when you have environmental responses, this is another facet. It's a temporal facet, but it's a very different temporal facet. If you work in immune cells that can switch their states and their differentiated states between different things like T cells, then you think about that very substantially. You have developmental features for the cell, you have environmental ones, you have ones that are the cell next to the cells that are around it and are impacting it. And we actually want to capture all of those things. And each of them could impose a different type of ontology or an abstraction structure, and we need to leave room for all of them. By the same, what I really loved about that perspective is that this perspective highlights that people in their wish to discretize cells and focus on one particular construct might be overdoing it at the expense of other ways in which you should look at cells. But the developmental one, which is fantastic, is just one additional one that we need to do. We actually have a whole series of them to go through. And finally, if Dana were here, she would say that. So I'm saying it also on her behalf. We are also very obsessed with taking the cell and putting it in a category. One cell can belong to multiple categories. It doesn't have to belong just to one. And moreover, within one cell, there's multiple gene programs that are running, and identifying those and building the dictionary of those and their relationships is just as important. So it's a wonderful perspective. I think it challenges everyone not to get fixed into one idea, but the atlas itself is not the metaphor of how, or actually it's not the abstraction of how you actually then characterize cells. It's about the need to have abstractions like that and the data from which to infer them.
And I'll just add that we have a session at the general meeting in Toronto about how to think about cell function, how to discover cell function, and how to validate. Many of the points that Aviv mentioned will be discussed. So I hope people can join and think about this, because we really don't know the best way to define and represent cell function yet.
Great. Sarah and then Fabian.
Yeah, so just to add to what's been said before on this topic, the lineage and the tree that's being discussed in the paper is a really kind of extremely powerful and useful and important framework for annotation. At the same time, there are cell types, and they include both, lymphoid, myeloid, epithelial, stromal, and so on cell states that are very convergent and come through different developmental pathways, and yet they converge onto the same phenotype. And so we don't want to constrain ourselves, I would say, unnecessarily to one paradigm for describing cells. And we want to integrate developmental, ontology and information and data wherever we can and wherever it's helpful, but not kind of in a blinkered way that excludes other types of information that are useful. So that's. I'll hand over to Fabian. I think you're on mute, Fabian.
Sorry.
Yeah.
That still happens. I wanted to briefly add this one point that I think it's key to have in your mind what you want to use the atlas for. So I think the point that Avi just made, or also you, Sarah, that the atlas is not the annotation, I think is absolutely crucial. There are lots of examples where this idea of an annotation of a cell type or things like that, we humans might need, but the application actually doesn't need it at all. Sometimes we just need to integrate things. Sometimes we want to maybe understand just the atlas for particular organ as a null model to see what's differential. And that must not necessarily be then described as a cell type. Sometimes we want to use this atlas maybe into a larger scale perturbation screen where a pure machine learning driven thing is the way to go. Let's look at images. Remember early on in machine learning, we tried to categorize things into the little bits and pieces and sort of build our own features. Of course, the thing en vogue with deep learning or with large language models, Aviv, you mentioned this now, right? To build big foundation models is to, in a set of unsupervised fashion, just find the features in there. I think most of us will agree that gene ontology and so on is a bit of an outdated thing. Nowadays, we can drive and maybe really build these things in a purely data-driven fashion from what we have. You might not yet have names for that. That's where I think CAP and related things are important to then give these names. But we know that the data-driven features are always bad. It's very hard to beat these, right? That's how they've been generated. So I think it's an exciting time to have then sort of the purely data-driven thing here, then the interpretation, the explainable part over there. And sometimes maybe this is totally fine. But then, of course, to make something in our mind, we need the other part.
Maybe I'll close on this, John, by highlighting two things for the people who still are listening to us. I know it's getting late. The first one is a cell doesn't have just one label. It's many things at the same time. It's in a phase in its cell cycle. It is responding to many signals. It has a certain developmental history, to Jay's original point. It has a certain set of neighbors, and at this, at that, and so on. Our goal is to try and find out all of those things. But if we put ourselves in a bind and insist that there's just one thing, any answer is going to end up being partial. Not wrong, just partial. So we need to be very careful not to fall into this trap. And I know we all do, and then we all have to pick ourselves out of it. And that's why I thought that piece was very interesting. The second point I will make, and as Fabian said, data-driven approaches and unsupervised approaches are one way in which we can get ourselves to see things that we wouldn't see otherwise, and so on. The second is that names do matter. They matter to how we communicate with each other. Matthias put a comment in the chat earlier, Matthias Kretzler, saying we shouldn't be headed to the Tower of Babel. So knowing that when we talk about a certain thing, we're actually talking about the same thing is where names actually matter a great deal. And by the way, they make our large language models bring back good stuff for us because we actually use those names consistently, and the LLM picks up on that. So we do need to annotate and give names because it's part of our kind of epistemological process of understanding what's out there in the world. It relates to our brain's work and how we communicate with each other, but we shouldn't become slaves to those as well. And that balance is part of what I think the Cell Atlas makes as a fun scientific and intellectual challenge.
Great, thank you very much. We're a bit past the 1 hour mark, and I think we've had a lot of really, really excellent questions and a lot of really excellent responses from our panelists. So I think that we will go ahead and wrap up. I do want to thank everybody here for attending, certainly the people attending online, as well as our panelists who've really been terrific. Thank you, Aviv and Sarah, for all the wonderful updates on HCA as well. Just to remind you that there is a webinar on the future of spatial omics on May 11th. So we hope that you will also be able to join that webinar. Certainly hope to see you either or both at the general meeting in Toronto on July 10th through 12th, as well as the HCA Asia annual meeting in Kolkata at the end of November. And there is a question about the general meeting. So I will say that, yes, there will be actually a lot of breakouts, a lot of small group discussions at the general meeting. And we will be making provisions for people remote participants to ask questions as well, that we will actually read out live in the room and then enable people to answer live. So really hoping to maximize participation as much as possible in both meetings. So again, thank you very much. And with that, we will conclude.
Thank you, John. Thank you, everybody. Lovely to see you.
Thanks.
Bye.
Thanks, everyone.
See you.
Bye.